For over 40 years, Unilock has recommended specific base materials and installation methods to ensure that paver projects are built to last. A solid paver base is made up of two very important parts. Number 1, base material that drains properly, and 2, base material that has enough load-bearing capacity for the type of use or traffic. Unilock has traditionally recommended a main base of 6 to 14 inches of 3/4-inch crusher run gravel, along with a 1-inch thick bedding course of sharp concrete sand. This base structure is designed to ensure proper drainage and optimum load-bearing capacity in most soil conditions. Poor base materials along with poor drainage will cause a pavement to fail regardless of the pavement type. Even with the correct base materials, a base can still fail if not sufficiently compacted. Decades of in-depth experience with permeable pavers have enabled Unilock to monitor and better understand the performance of permeable installations, both commercial and residential. Based on the success of these projects and the installation benefits that can be realized, Unilock now recommends that you consider using a permeable base model for your non-permeable paver installations when appropriate. Let's take a closer look at what a permeable base model looks like for a typical driveway or patio application. The base consists of the following. The main drainage layer is comprised of graded 3/4-inch clear gravel, often referred to as 57s, which is an ASTM gradation. ASTM 57 is a clear graded gravel consisting of stones averaging 3/4 of an inch in size. You may also decide to use a layer of ASTM number 2s first, which is made up of coarser stones with pieces averaging 2 inches in size. The material used in the top layer of the permeable model is the 1-inch thick bedding course, which uses a similar material but with a smaller sieve size, such as a number 8 or number 9. If ASTM graded gravels are not available from a supplier in your area, simply seek out a supplier who can provide you a clear graded material. The key is that you use only clean graded materials for maximum performance. The following is a demonstration of permeable base installation for a residential driveway using non-permeable Unilock pavers. The best practices for excavation are the same for both traditional base projects and permeable base projects. Based on the usage, slope, and the site soil conditions, the depth of excavation may vary. In this driveway project, the subsoil is heavy clay, so it was determined by the contractor that a 14-inch base would provide the best results. An overdig of 6 to 8 inches is always recommended to prevent edge settlement. Excavating an inch or so below the base of the street curb prevents any water from building up in the driveway base by allowing water to drain into the street base material. Any loose subsoil resulting from excavation should be compacted to prevent settlement later. However, do not over-compact the subsoil. Doing so can discourage the flow of water back into the soil, especially in very level installations or clay soils. It is important that the perimeter soil does not leach into the clear stone base and eventually clog it. To prevent this, a strip of filter fabric is used. The fabric consists of a material that will prevent particulate from flowing through, but will allow any water to flow through. For the bottom of the driveway, a geogrid or filter fabric is used to separate the clear gravel from the subsoil. Note, if filter fabric is used, it must be permeable. For this project, geogrid was chosen for maximum water flow and additional structural strength. Both geogrid or woven filter fabric will prevent aggregate from traveling into the subsoil and vice versa. Another benefit of geogrid or permeable woven filter fabric is bridging, which simply means that if there is any random settlement in the subsoil, the geogrid or the fabric will help support that area and minimize settlement of the pavement base. The geogrid being used here is Terrafix TBX 2000. For patios, a permeable filter fabric is sufficient. When choosing a cloth or grid, always follow the manufacturer's specifications. Once the perimeter filter fabric is in and the base geogrid is in place, the area is filled in with the 57s or 3/4 inch clear stone. This stone must be made from crushed material and cannot be comprised of round stones. Angular pieces of stone lock better and will not roll when compacted. Prior to placement of the 57s, conduits are installed to accommodate irrigation pipe and lighting wire. Placement of the 57s is rapid and is easily accomplished using a swing hoe or uniloader. Although clear stone cannot be compacted like regular crushed run gravel, it's still important to make several passes with a compactor to rattle or nest the angular stone pieces. In order for proper vibration to take place, use only the bare plate with no paver protector attached. As with traditional base compaction, compacting in layers is best unless a large 2-ton reversible compactor is used. Once compaction is completed, screed bars are set into place for the correct elevation and slope to be achieved. Once the screed bars are in, the bedding course material is placed and screeded using a straight board or level. Doing a rough rake first makes the screeding go much easier. Contractors generally find that working with clear material is much easier than working with other gravels and sands, which easily become water-laden after a rain. With clear stone, crews can continue to be productive in rainy or even freezing weather conditions. After screeding is complete, the pavers are installed. Laying pavers on clear stone is easier than on sand, because divots from footprints are less likely to occur. Although it is always better to walk on the pavers that have just been laid, you can from time to time step on the screeded surface. Do not turn your feet while stepping, or you will shift the bedding material. Once the pavers have been laid and any final pieces cut, the unrestrained edges must be secured. If the perimeter of the paver installation is not restrained by concrete walls, curbs, or some other type of permanent barrier, a plastic or metal spike-in edge restraint is required. Edge restraint is typically spiked in using 10 or 12-inch spikes spaced 24 inches apart, but in permeable base materials, it is recommended that you place a spike every 12 inches. A special edge restraint for permeable applications is also available and can be used. It comes with an attached mesh that is placed under the perimeter stones to provide a secure edge. After the edges are secured, the surface is compacted like any other paver project. To prevent scratching the paver surface, a protective pad must be attached to the compactor, and you must ensure that the entire surface is clean and free of debris before any compaction is done. We recommend 2 or 3 passes. It is also very important to note that no jointing sand should be put in the joints before compaction. Regardless of your installation type or paver type, you should never put any sand into the joints prior to tamping. Doing so will not allow you to flatten the surface properly. After the final surface compaction, the joint sand is put into the joints. Because of product textures and joint size, polymeric jointing sand is not always recommended. Always check Unilock.com for product-specific joint sand. On this project, ordinary coarse masonry sand was used so that the paver texture would not permanently trap sand or dust on the surface. The best way to fill the joints with masonry sand is to wash the sand in like typical mortar grout. By using this method, no settlement of the joining material will reoccur after leaving the project. The paver surface is also effectively cleaned by using this method. One person applying water with a garden hose and one person using a squeegee or broom will get the job completed quickly. Liberal amounts of water are required to successfully flow the sand into the joint from top to bottom. Even though the gravel below is open graded, the sand will still stack and lock better when washed in rather than swept in dry. For additional joint stabilization, a joint sand stabilizer sealer can be applied after the joint sand and the pavers are dry. Clearly, you can see that there are some advantages to using this base method. However, it's important to note that not every paver project can be installed on a permeable base. Let's examine the pros and cons of using permeable bases. The pros are: open graded aggregates minimize or eliminate potential frost movement. Open graded aggregates are almost self-compacting, reducing the possibility of settlement. Open graded aggregates are ideal for raised patios and steps because the bedding course cannot wash out. An open graded bedding course can be walked on during paver installation. Open graded aggregates minimize the risk of base washout from downspouts. Weeds have difficulty rooting and thriving in open graded aggregates. Ants and other insects cannot set up home in open graded aggregates. Pavers can be laid on open graded aggregates in wet or frosty weather. The cons are: open graded aggregates are not available everywhere. Filter fabrics must always be used when abutting lawn and garden areas. More planning is required when combining 6 and 7 centimeter products. Open graded aggregates do not have as much give when doing the final compaction. Horizontal drift may occur from vehicular wheel forces if edges are poorly restrained. However, as you can see, the pros outweigh the cons, which is why the use of permeable-based systems is gaining traction across North America and in Europe. With its many advantages, we recommend that you consider trying this method for your next driveway, patio, or pool deck project.